We want to have a look now at molar mass and the mass of 1 mole. Let's have a look at what it says here. It says the mass of 1 mole of a substance is equal to its formula mass expressed in grams. Now what that means is if we have, so for example, water, and if we find the mass of its formula, then we take that and we express it in grams, and that is a molar mass. So the mass of 1 mole of atoms of an element is equal to its atomic mass expressed in grams. Now, atomic mass is measured in what are called atomic mass units. Now, what that means is that when we're having a look at the mass, let's say, of 1 hydrogen atom, then the mass of oxygen, we find that this is round about 16 times heavier than hydrogen. So this is a different scale that is used. So the scale is atomic mass units, not grams. But what we do then is we take that formula and we say, okay, we'll make that grams, and then that then becomes the mass of 1 mole. Well, let's have a look a little bit further. A formula mass of a substance is the sum of the atomic masses of all of the atoms in the formula of a substance. And that is measured in atomic mass units. So hydrogen is round about 1, not exactly 1. Oxygen is round about 16. So if we were looking at water, H2O, it's round about, not exactly, but round about 18 atomic mass units for the mass of 1 formula or 1 molecule of water. So the formula mass of an element, this is just a substance that is made up of only 1 type of atom. That's what an element is. So hydrogen, helium, oxygen, carbon, they're all elements. They're all substances made up of 1 type of atom only. So the formula mass of elements is the same as their atomic mass. So we're just looking at the 1 atom. The formula mass of a covalent substance is also called its molecular mass. So it's a mass of the molecule. The molar mass of a substance is a mass of 1 mole of the substance. Or, if you like, 6.02 by 10 to the 23 atoms of the substance. So let's have a look then at the exercises. This first one. What is the mass of 1 mole of the following atoms? What I've got to do now to get the mass of the mass of 1 mole of oxygen is to go to the periodic table, find its atomic mass in atomic mass units, and then express that in grams. So let's go now and have a look at the periodic table. So now I've got up here the periodic table, and I don't know if the screen allows you to see that up here this says 16. So that is the atomic mass of oxygen in atomic mass units. So the mass of 1 mole is 16 grams. So let's write that down. So here we write 16 grams per mole. Now for the next one, calcium, again, what we need to do is go to the periodic table. So if I change now to the periodic table and find calcium, that's Ca. Here it is here. I don't know if you can see that that is 40.08. So going back to here, our answer is 40.08 grams per mole. Now I can write it as grams per mole like that, or I can write it as grams moles to the -1. Doesn't matter too much which way we write it. For copper, let's have a look at our periodic table. Copper is along here. Copper has the formula, has the symbol, I should say, symbol of Cu, and its atomic mass units, its mass is 63.55. So we go back here, 63.55 grams moles to the -1. Argon, that has a symbol Ar, so we have a look at that one as well. Now argon is located over here in the periodic table. You can see its formula, its symbol, I should say here, Ar, and its mass, in atomic mass units, is 39.95. So we go back, 39.95 grams mole to the -1. Uranium. Now uranium has the formula U, so we look at that one, and it's down here somewhere. I always have to poke around just a little bit to find it. I hope you can see it there. It's 238. So we go back, 238 grams per mole. And lastly, silver. Now silver, the symbol for silver is Ag, and that comes from the word argentium. And let's go back to our periodic table to check that one out. And silver, Ag, we get used to where it is after a while. There it is there, and it's 107.9. So crossing back, 107.9 grams per mole. So what we saw was these figures, first of all, in atomic mass units. So when we say atomic mass units, that roughly translates to how much heavier these, or how much bigger the mass is of these atoms compared to hydrogen, which is around about 1, or carbon, more accurately, carbon, one of the isotopes of carbon, carbon-12. But that's another long story. But basically it's saying in atomic mass units how much heavier it is than some of these very, very smaller ones. And when we find out how much heavier it is, how much bigger the mass is, we then turn that into grams. We just say how many grams that is. And that is the mass of 1 mole. That is the mass of 6.02 or 6.022 by 10 to the 23 of those. We'll have a look at these in the next video.